to IR, VC is equal to IXC. 3. Voltage V is equal to IR, which is equal to IZ, which is equal to IXC, which is equal to IXL. Example 4. Figure 4.8 show the diagram example. Calculate the following series circuit shown above. A. Reactance of the capacitor. B. Impedance of the circuit. C. Current through the circuit. D. Voltage across the capacitor. E. Average power used in the circuit. Solution. A. Reactance XC is equal to 1 over 2 pi FC, which is equal to 1 over 2 times 22 over 7 times 25 times 10 times 10 raised to power minus 6. XC is equal to 636.6 ohms. B. Impedance Z is equal to square root of, in bracket, R squared plus SC squared, which by substituting the values we now have square root of, in bracket, 10 raised to power 6 plus 405,004.96, which will give us 1185.3 ohms. C. Current I is equal to V over Z, which is equal to 90 over 1185.3. I is equal to 0.076 ampere. The voltage VC is equal to IXC, which is equal to 0.076 times 636.6, which is equal to 48.38 volts. E. Power is equal to I squared R, which is equal to 0.076 squared times 10 raised to power 3, which is equal to 5.78 watts. Example 1. A series circuit consists of a capacitor of 1 μF and a resistor of 500 ohms. An AC voltage of 6 volts, in bracket root mean square, and frequency 25 Hz is applied. Calculate the A. Current flowing. B. Voltage across the capacitor. C. Phase angle between current and voltage. D. Average power. Solution. The reactance XC of the capacitor is given by XC equals to 1 over 2 pi FC, which equals to 1 over 2 pi times 25 times 1 over 100, which will give us 0.6366 omega approximate. Z is equal to square root of, in bracket, R squared plus XL, which equals to square root of, in bracket, 500 squared plus 6,366 squared, which will give us 6,386 ohms. A. I root mean square is equal to V root mean square over Z, which is equal to 6 over 6,366, which will give us 9.4 times 10 raised to power minus 4 amps. B. Voltage across the capacitor VC is equal to IXC, which is equal to 9.4 times 10 raised to power minus 4 times 6,366, which will give us 5.98 volts. C. Tan phi is equal to XC over R, which is equal to 6,366 over 500, which will give us 86 degrees. D. Power supplied equals to P equals to I squared R, which will give us 0.00044 watts, or equal to 4.4 times 10 raised to power minus 4 watts. Example 6. A current having a resistance of 10 ohms and an inductance of 0.05 Henry is connected across 50 volts 60 Hz supply. Calculate A. Current. B. Phase angle between the current and applied voltage. C. Power factor. D. Power. Solution. Figure 4.8 shows the circuit diagram while 4.40 shows the resolved diagram. A, for the question A, I is equals to V over Z, which is equals to V all over square root of, in bracket, square arrow squared times SL squared. SL is equals to 2 pi FL, is equals to 2 times 3,142 times 60 times 0.05, which is equal to 18.85 ohms. Z is equal to square root of, in bracket, 10 squared plus, in bracket, 18.85 squared, which is equal to 21.34 ohms. I is equal to V over Z, which is equal to 50 over 21.34, which is equal to 2.34 amp. B, tan theta is equal to IXL over IR, which is equal to IXL over R, which is equal to 18.85 all over 10, which will give us 1.885. Therefore, theta is equal to tan inverse of 1.885, which gives us 62 degrees. Question C, power factor is equal to cos theta, which is equal to cos 62 degrees, which will give us 0.469. D, power is equal to VI cos theta, is equal to 50 times 2.34 times 0.469, which will give us 54.87 watts. Example 7. Figure 4.41 shows a circuit diagram of the example. If the frequency of AC circuit illustrated above is 500 over pi hertz, what will be the reactance in the circuit? Solution. In the LC circuit, the voltage VL and the voltage VC are out of phase by 180 degrees. Reactance capital S is equal to square root of XL minus XC squared. XL is equal to 2 pi FL, which by substituting the values we have 2 pi times 500 over pi times 0.9. Therefore, XL is equal to 900 ohms. XC is equal to 1 over 2 pi FC, which is equal to 1 over 2 pi times 500 over pi times 2 times 10 raised to power minus 6, which gives us 1 over 2 times 10 raised to power minus 3, which is equal to 10 raised to power 3 over 2, which gives us 500 ohms. S is equal to square root of, in bracket, 900 minus 500 squared, which gives us square root of 400 squared. S is equal to 400 ohms.